So we asked whether the same thing was happening in areas of the marsh where grass was dying and turning into a mudflat.
Wow, check out the snail front, Joe. There's 200 snails on these 6 stems right here. So there must be tens of thousands of snails right here, creating a big battlefront where they're killing the grasses.
Again, we used cages to test what would happen if we excluded snails from a die-off area.
We saw a mudflat the size of football fields, and in the middle of that, we saw this chia pet of grass. Often there were snails piled on the edges trying to get into that cage of healthy grass. It looked like giant tufts of hair coming off of a bald head.
So these experiments told us that the abundance of grass in marshes, which are full of periwinkles, is in part controlled from the top down. But the experiments also showed that given the chance, the snails would eat all the grass. So the next question is, what is keeping the snails in check?
Because whatever controls their numbers and suppresses their abundance is indirectly going to have a positive effect on the plants. And one of the animals that utilizes the marsh the most to find its prey are blue crabs. They're freaky fast on their feet, and when they eat, they can grab a snail or a mussel, pull it towards their mouth, and eat it in about 15 seconds. To look at whether or not blue crabs were suppressing snails, we tethered snails. That's when you glue snails to little pieces of fishing line that's tied to a little PVC pipe. And voila, we are now serving snail on a stick.
We placed these snails in areas where the marsh looked healthy, with lots of grass, and in areas with little or no grass. After a couple days, we checked the areas where the grass was healthy.
I'm going to start here, and then I'm going to make way down here and just check the tether.
Okay.
Yeah, number 1.
Okay.
Ah, look at that.
I feel like I
got tagged last night. Snail is missing. Small shell fragments. Number 10 is that we have a survivor. So 1 survivor out of all those dead. We have 90% of the snails were killed. Those blue crabs are voracious.
Next, we needed to go check the snails left in areas that didn't have much grass.
Okay, here's the last tether. Snails intact, still alive. No sign of predation. All the grass is dying and there's lots of adult snails. And it really illustrates the interaction that we've been seeing. All of them survived and just 1 died.
The experiment suggests that where marsh is healthier, there are fewer snails because they are being eaten by the blue crabs.
But this is just correlational. It suggests that there's a relationship, but there could be other reasons the snails don't like that area. So we then used an experiment. We put cages out again, and we excluded blue crabs from these areas. Baby snails came into the marsh. They have planktonic larvae, and over a 2-year period, the snail numbers increased inside cages where we did not allow blue crabs access.
Here, all the grass had died off.
Hence, the blue crabs are protecting the salt marsh.
We call these indirect effects from predators to herbivores to plants trophic cascades. In this case, the crabs protect the grass by controlling the number of snails, who, if left unchecked, would eat all the grass. And so now we understand there is a connection between those grasses and the grazers and the predators in the system. When we lose blue crabs, potentially from overfishing or other processes, we'll see that those snail fronts can expand and the numbers increase even more in these salt marshes. It's going to be important for predators to be around to keep those grazers in check, because once they're unleashed, they can destroy the marshes and the services they provide. It took a while for people to accept the role of top-down factors in salt marshes, because it's the opposite of what scientists used to think. I think there are a couple of important lessons that I learned from my study of salt marshes. Sometimes observations you make yourself don't match the theory. Don't be scared if those don't match up. Trust your instinct and figure out ways to confront theory with data, because that's how we move science forward.